So one of the things about being a software architect is that I've had to go beyond what a lot of developers typically know. I've had to delve into security and network administration, and I've gained a lot of knowledge over the years about things that are related to programming and the technical decisions that programmers should make, but aren't actually handled by developers on a day-to-day basis. And one of the things that really annoys me is conversations about databases, because a lot of times I see people having conversations about, should I use an ORM or not? Are stored procedures bad or good? And these conversations are worth having, and there is some good information that pure developers give out. But one of the things I rarely see them talk about and really explain to beginners is how database security works and the considerations you should make around your data and how it's used in your application, and how that flows into decisions like whether or not to use an ORM. So today's video might be a little bit longer, but I'm going to go into a lot of topics, starting with just explaining how database security works for beginners, and then we're going to talk about these considerations and how they shape your choices when architecting applications. So let's start out with the very basics: authentication and authorization. Now, these are two security terms that have different meanings. Now, people will use these interchangeably sometimes, but it's not really correct. But if you're in the field, you usually can figure out what people mean by the context. Now, authentication is how you prove you are who you say you are. So your username and password. That is one means of authentication. You can also have two-factor authentication, where they send you a code on your mobile phone in text, or maybe you use an authenticator app to log into a database or a security system. Now, authentication, proving who you are. There's two ways that databases typically handle authentication. And the first way is to have a SQL account on the database. So literally in the database, you will create a user and a password, and you can give that to a user or assign it to an application, and they will use that to authenticate to the database. The second way databases handle authentication is to use domain credentials. And what I mean by this is, if you go work for a company and you go into the office, you're going to have your company PC, and you're going to type in the username and password that your company gave you that lets you into their systems. And then it lets you access things like network drives, applications, things like that. And there's a technology called impersonation. And basically what that means is that if you're using an application and it connects to the database, it will pass your company credentials on automatically without asking you to log in again. And you can also create domain accounts for applications. They don't have to be assigned to people. They can be assigned to processes and applications and other things. Now, this is more common in small, medium businesses and larger environments that actually have like a Windows domain or a Linux domain or some domain controller that is running the management of all of those user accounts. And that is the most common and most secure way to do authentication to databases, because then it's all centrally located in that network domain controller, and your network administrators can enable and disable accounts and change their permissions, all in that central source. With SQL authentication, that authentication only exists in that database. So if you're in an environment where you have many databases and each of them has a bunch of SQL accounts, that can become very cumbersome to manage, and people can miss things, and it just does not scale well. So in smaller companies or on individual projects, it's awesome because you may not have a domain controller, or you might not want to deal with one. Perfect for there. And if you're learning and you're doing tutorials, you'll almost always see SQL authentication. Like in my courses, you download a database in a Docker container. Well, we're not on the same domain. I don't control your credentials. So using SQL authentication to log into those container databases is the way to do it. It's the easiest and fastest and most convenient way, but it is the least secure. And when we talk about these authenticated accounts in SQL, there's one in particular that you're going to come across a lot, and it's SA. And that stands for System Administrator. Now, in database land, SA is the God account of the database. It can do whatever it wants. It can create databases, drop databases, it can access any data, it can change the encryption scheme. That account is very valuable. And while a lot of people do use it during development because it's convenient to be able to do anything, that is something that should never be exposed to production. You should never be running an application as SA. None of that. Very dangerous. But a lot of beginners, they don't know that and they do it. So that's authentication. Now, authorization is what determines what an authenticated user is allowed to do. And that starts right away. Like, are they even allowed to connect to a database? Because a database server can have more than one database, and you can authorize those users to only be allowed to access certain ones. And then within a database, you can go down to a very granular level. You can say you can only access these tables. You can say you can only select from these columns. You can't insert at all. You can update, but you can't delete. These are all things that you can set with authorization. And in databases, there's basically two ways that you can handle authorization. And the first is account-based. So for your user account, you can specify what they are authorized to do on that database server. And the second and more common is role-based. Now, in databases, a role is kind of like a group. Now, I don't want to confuse the word group because we also use it over in network administration on the domain, but a role basically says anybody who belongs to this role can do these things, and you can grant or deny access based on the role. So as an example, let's just say we have some data analysts that work at our company, and they should be doing reporting for our executive team. But they should never be changing the data. They shouldn't be inserting, updating, or deleting. They should only be selecting it for the purposes of reporting. We could create a database role called data analyst, and we could assign it select privileges to whatever tables those data analysts are reporting data from. And you could also not give them access to tables that they shouldn't be using for their reporting, so you can make their scope very limited. Now, on the network domain side, there's also a concept called groups. So you might have a data analyst group in the domain controller, and when your network administrator creates a new account, like you hire a new data analyst, they will put that user account into the network group. And then over on the database, they will put that network group into the role. And what that does for a network administrator is it makes it really easy, because when they're managing user accounts, they can just put them into domain groups, and then they'll automatically get access to the roles on the database server. And that's how big companies typically do this stuff. But the main point of authorization is that you should always follow a principle called least privilege. And that means when you're giving a user access to a database or you're creating an application, that application should only be authorized to do the things that the application absolutely needs to do. And when you're in development or testing and you're running your application as SA, System Administrator, it's allowed to do anything. And that is absolutely wrong for production if you care about security. So again, as an example, Let's say that I have a small application, a batch job. And what it does is it goes out into the invoice table and it pulls up all the current invoices and grabs the customer address and the information about the invoice so that we can mail or email them a statement. That batch job should have an account, regardless of whether it's domain or SQL, but that application's account should only be able to select data and columns from the tables that it needs to do its job. That application should not be SA. It does not need to be SA. Now, the reason you do this is out in the wild. When you have web applications, mobile applications, you have services running on servers that aren't your database server. If those get compromised, if somebody hacks that account or finds out the credentials or hijacks one of the processes, one of the first things they'll typically do is try to get into your database, because that's where all the valuable information that hackers want to sell is. That's where the billing is. That's where all the personally identifiable information is. And if you use least privilege, then if one of those applications gets compromised, it can only do the things that you allowed them to do. And if you limit the scope of it enough, even if it's compromised, it won't be very useful to the hacker. Now, if they hijack the SA account, now all of a sudden they have the keys to your database and they can do some very malicious things, even create their own accounts that you might not notice and start continuously querying your data and just stealing everything. So this whole least privilege thing is something that professional developers think a lot about. What is my application? What is the minimum authorization that it needs to do its job? And then you set up your authentication accounts and your authorization permissions accordingly. So now let's talk about database objects. Now, almost everybody is aware of what a table is, but there's two other types of objects that come into play when we want to talk about application security. And the first is something called a view. And you can think of a view as a virtual table that's based on a query. So I can write a query with a bunch of inner joins and I can give it a name, and it's not a table. I'm not going to go super technical into this. It's not a table, but for the purposes of writing a select query, it acts like a table. It's just based on a query. And what you can do with views is you can define a query that has a subset of columns, and maybe a bunch of tables are already pre-joined. And then instead of authorizing a user or a role directly to a table, you can authorize them to the view instead. Because in database security, if you grant access to a view, or we're going to talk about stored procedures in a minute, if you grant access to those objects and they're based on underlying tables, the user is allowed to use the view and get that data out of the view, but they're still not allowed to touch the tables underneath the view. So this, for security, is an extra layer of protection, because if the columns are not returned by the view, they can't be selected by the user at all. And again, when we go to that compromise scenario where your application gets compromised or your account gets compromised, now all of a sudden the attacker only has access to the view and those columns. Now, another level down, we have something called a stored procedure, or, it's basically a function for the database or a method. You give it a name, you can pass parameters in and out, it can do a whole bunch of stuff. You can write any SQL you want in a stored procedure. So you can write a whole batch job, you can write just a select query where you get a user by ID, you can insert, update, delete. Any SQL can go into a stored procedure. It's just a method or a function on the database. Now, this is an additional level of security. I usually build my applications using stored procedures when the information in the database has high security needs. Because, again, the store procedure can access the tables. But if you only give the application accounts and the user accounts access to the store procedures, the only thing they can do is execute those store procedures, which means I've effectively trapped them if they got compromised, because they can only do the specific things and run the specific queries that are in those store procedures. If you have direct access to a table and you have select rights to that table, you can write any select query that you want. You can filter it with where, you can not filter it, you can aggregate it, using groupings. You can do any query you want. But if I have a store procedure that says, hey, you can select one user from this table by ID, well, now that's the only thing the hacker can do. And if I have 10 million users in my table, they would have to find all 10 million IDs and they would have to execute those queries one at a time, calling that store procedure, because they don't have rights to do anything else. So those are the three types of database objects. And again, if you're looking to be the most secure, then only granting access to store procedures is the most secure, because the store procedure limits their ability to do anything else. They cannot write custom queries unless you do something really dumb, like create a store procedure that lets you pass in custom SQL into, which you can do. But again, don't do that. It's dumb. And now we're ready to talk about accessing databases with your code. Now there's two general ways you can do this. The first is that you can have a database provider, and that's going to come in a library or a package or a gem, depending on whatever language you're using. There's some way to download packages and use them in your application. Now, a provider for your database is going to allow you to do things like create database connections and write SQL that is going to be sent to the database to be executed, and then you're going to get data or status responses back. And that allows you to write your SQL in your application or invoke stored procedures on the database. And you're in complete control of that, but you have to write a lot of that code, and it's very verbose and it's very granular. Now, this is great in situations where you want high performance and higher security, because you have complete control over what gets sent over the wire. The other approach is to use an ORM, which stands for Object Relational Mapper. Now, an ORM is a very useful tool. It will automatically, with minimal configuration, generate queries for your database. So you can oftentimes, some of these ORMs, you can point them at a database. It will scan all the tables in the database. It will create objects in your application, and then you can just use it to say, hey, give me all the customers, and it will create all the SQL in the background, query the database using the query that it thinks it should run, and you'll just have your data. No muss, no fuss. ORMs are awesome. I'm not going to hate on ORMs. I don't personally use them because I like to have that granular control, and I tend to work on databases that have a lot of secure information in them. But they are awesome for getting something up and running quickly. They're awesome because if you as a developer, if you're not comfortable or competent in SQL, they can do a lot of that work for you and make you more productive. Now, when it comes over to security, as I already foreshadowed, the problem with a lot of ORMs is that they're really tailored to work with tables directly, because they want to select, insert, update, delete, and just be able to do it seamlessly with minimal configuration. Now, this is where the ORM crowd is going to jump in and they're going to say, hey, but Eric, you can totally make an ORM call a stored procedure or a view. Yes, you can. but you usually have to write special things or configure things in a certain way to get that working. So it kind of takes away the benefit of the auto configuration and ease of setup. And I always say, if you're going to do that anyway, just use a provider that has some shortcut functions and then you don't have to deal with all the mess of, using an ORM in a way that it's really not intended to be used. It's more of a pick the right tool for the right job situation. So if you have a website, you're only selecting data, it's not a big security concern, go ahead and use an ORM. It's going to save you a lot of time. If you have a complicated application that has high security concerns, then you should use a database provider and you should take control of that process. You're going to get better performance, you're going to get better security, and it's just going to be better overall. Now, I'm just going to aside on a mini rant right now for all you beginner developers out here. You need to learn SQL. Do not learn an ORM to avoid learning SQL, because eventually you are going to run into a situation where a query is really complex, it doesn't perform well, or there's security concerns or something, and you're just not going to know what to do. Not knowing SQL is a career-limiting decision. Learn SQL, please. And since we're down at the application level, this is where I mention SQL injection attacks. SQL injection attacks are a way that hackers can compromise your queries, especially when you don't have your roles and your database queries limited, like I've talked about in this video. And what they'll do is, in an application, like you might have a text box where they're entering something into a form, and they will write SQL into that text box. And you can go look up some videos on SQL injection. It's very common, and it's downright embarrassing when it happens to a developer because there's really no excuse for it. It happened to Sony. Their PlayStation network was vulnerable to a SQL injection attack, and I just got to tell you, as a software architect, as a professional, I see something like that, and I'm like, what are you doing? Like, no excuse for that. But basically, they'll try to write some SQL in a form or in a URL or something, and they'll try to inject it into your application and force your database to give up extra information or do bad things so they can get access to your system. Now, the way you avoid this is to parameterize your queries. You should never use string concatenation for a SQL query. And I'm going to repeat that because it's important. You should never use string concatenation for a SQL query. All of those frameworks and libraries I mentioned, they have ways of creating and passing parameters. It's called parameterization. We're not going into specific code in this video, but look it up. Never write queries without parameterization, ever, because it will make you vulnerable to SQL injection attacks. Now, the other thing you need to be aware of is your database keys, because in applications, if you want to update certain records or display rows or drill down into details, you are going to need to provide the keys that reference the data in the database. Now, sometimes that information is harmless and it's okay, but there is another trick that attackers tend to use, especially in web applications. You'll look up in the URL and you'll see something like example.com/profiles/5. And anybody who's an experienced developer knows that that 5 is probably an ID record for a row in the database. Now, does that matter on its own? No, because 5 doesn't have any meaning. But what if the user goes up and changes that to 6 or changes that to 10? Now, you might not care. If it's a product ID and you're on a retail website, well, so what? They're going to change that ID number and they're going to look at a different product. That's not really harmful. But in the case of a user's profile, that means you also need to check on that profile page whether the current user should be able to see profile 10. So there are times this is something you need to be aware of. There are times when somebody manipulating a database ID could expose information that you don't want them to have. And when that happens, you need to write defensive code. And there's other times where it doesn't matter. And, a lot of the time it doesn't matter at all, and you can just roll on with your life. but it's something every professional developer should think about when they're building applications. So that was a lot of information, but I can tell you as somebody, as a career software architect and a hiring manager, oftentimes when I interview developers, there's some pretty significant gaps in their knowledge of SQL and their knowledge of security, and especially how all this database stuff works, because most of the online courseware and tutorials out there, they're really focused on just slapping an ORM in there and just getting your application data working, and they don't really consider what an enterprise environment really looks like when it comes to interacting with databases and properly securing your applications. So I hope this was helpful, and I hope you took notes and you got a nice list of things that you should look deeper into, because it will make you a better developer if you learn SQL and you learn the basics of database security and administration. You'll be a lot stronger, and you'll be more capable if you ever decide to make your own real applications or real projects where you go that entrepreneur, contractor, small startup team route. This is required knowledge if you're going to go that direction. So that wraps things up. Database security and this type of decision making about what types of tools to use are things that separate beginners from professionals. So I hope this was helpful. If you want to learn how to be a professional coder in the C# language, you should head over to skillfoundry.io. That's where I keep my courses. As part of the subscription, you get access to the Discord community where myself and other experienced professionals hang out, have conversations, answer questions about topics like this and more. I'd love to see you over there. Happy coding.